We're going to look at graphing sine and cosine. We only have a short class left. So I want you to open your book. So open your book to page 386. Now, unfortunately, the internet is not working, and I'm having these problems, but we can get by without it. So you need to have a graphing calculator because we're going to be looking at graphs. So you can take mine if you don't have. Where did my other one? Does everyone have them? Okay, so let's go to, if you look on page 386, table 6.7, what they have there is the values of sine. So like in radians, so 0, pi over 4 is radical 2 over 2, which is approximated 0.7. Pi over 2, the sine is 1. 3/4 pi is radical 2 over 2, and they plot that data. And this is what you get when you plot a sine function. Now, it goes on indefinitely from negative infinity to positive infinity. But this is one cycle of your sine function, okay? So they show you down here more than one cycle. This is probably one of the most famous waveforms. Now, if we increase the amplitude to 3, this keeps the zero crossing. So now if you look at figure 6.55, if you increase your amplitude, so you have 3 sine x, the zero crossings are all the change, but it's same, but it's stretched vertically. If we think of what we did for transformations, like 3f of x stretches it vertically. Then they do 2 sine x below that, where it's stretched vertically by 2, and then below that they have, in that same figure, they have negative 2 sine x, which is the reflection. So remember, negative f of x, you are reflecting it across the x-axis. Figure 6.57, they've stretched it, so sine 2x they plotted. So sine 2x, remember, that is shrinking it by a factor of 2. So now all the zero crossings have changed, but the amplitude has remained the same. Then we look at the next one below there, sine x over 2. We have stretched it by a factor of 2. The amplitude remains the same. The zero crossings change. So I want you to graph with your calculator y equals sine x, y equals 3 sine x, and y equals 1/3 sine x. So you should have a window of negative 2 pi to 2 pi. Make sure your calculator's in radian mode. So when you last left off, I think you had it in degree mode. So if you go to your window to change it from negative 2 pi to 2 pi, and then you want to have a y window of like, negative 4 to 4, so that you can see everything. Your x window, negative 2 pi to 2 pi. Because what we're doing is we're looking at 3 cycles. Okay, so that is sine x. Then going up bigger is 3 sine x. And then coming down half as much is 1/2 sine x. Now, that they all have the same zero crossings. What we've done is shrunk it by a factor of 3 and stretch it by a factor of 3. Did everybody see it? Okay, now we're going to plot negative sine x. What you should see is the reflection. Okay, so you're plotting negative sine x. And you should see it reflected. If you're not seeing this, let me know. So you can see in purple here, negative sine x is the reflection of sine x. Now we're going to erase everything, and we're going to put everything except for sine x. So it doesn't get too cluttered. Erase everything except for sine x. And we're going to do sine 3x in parentheses, not 3 sine x, sine 3x, and then sine 1/3 x. So what you should see is that you have stretched it by a factor of 3 with the 1/3 sine x. Remember, in the horizontal, the fraction stretches it. And you shrunk it horizontally by a factor of 3. So you should see some very different sine waves. They do not share the same zero crossings, but they have the same amplitude. Did you see that? Okay, now we're going to look at cosine. Now the period, so on page 387, it says the amplitude y equals a sine x is a. So the number in front of the sine x is the amplitude. Then below that, it says the period is 2 pi over b. Okay, so 2 pi over b, where b is the number next to it. So what we have is sine bx, and the period is 2 pi over b. This number is the amplitude. So when we went sine 3x, our period was 2 pi over 3. And when we went sine x over 3, our period was 2 pi divided by 1/3, which was 6 pi. So the period is the time for one complete cycle. So if you change, you have to change your window all the way to negative 3 pi to see the whole cycle for sine x over. Okay, so now my period of the sine function, just sine x, is 2 pi because b is 1. But now that I changed that, what I see there in black is one complete cycle for sine x over 3. Okay, now we're going to look at cosine. So cosine is the same, has the same rules about amplitude. So if you look at page, I guess we should do this first. Okay, so at the top of page 388, they give you examples. 3 sine negative 2x. Okay, so that is, the amplitude is 3. The amplitude is the absolute value. The period is 2 pi over 2. Now, again, we take the absolute value. So your b is 2 there. The next one, they have negative sine x over 3. So therefore, this is your period, which is negative 1. And the period is 2 pi divided by b, which is 1/3. So 6 pi, as I just went through with you. Then they give you negative 2 sine 3/4 x. Okay, so your amplitude is negative 2. And your period is 2 pi divided by 3/4, which is going to be 4/3 times 2 pi, which is 8 pi over 3. So all you do is take the number next to the x, divide 2 pi by that to get your period, and the number next to the sign is your amplitude, and we take the absolute value. Okay, now on page 389, we graph the cosine. So it's the same values. Now you might have noticed, right? We keep repeating the same values, but they come at different points. So basically it's out of phase. If you look at the cosine here, you have 0, 1. It doesn't start at 0 anymore. Pi over 4.7, which is radical 2 over 2. Like that. Pi is -1. Okay, this is the cosine function. The cosine function is the sine function shifted 90 degrees. Now down below they have the cosine with multiple intervals. Now often someone might describe a cosine function as sinusoidal because it's only shifted by 90 degrees, so you can call it sinusoidal. They'll speak of something changing, like the seasons changing sinusoidally, daylight changing sinusoidally. Okay. Now we have the same rules. If we go to the next page, we have the same rules for amplitude and period, 2 pi over b. And they give you similar things here. 2 cosine 3x, your amplitude is 2. 2 pi over 3 is our period. So one complete cycle is 2 pi over 3. Here the amplitude is 3. We take the absolute value, 2 pi divided by 2/3. Everything else is the same. So let's plot some cosine waves. So I want you to plot cosine x. First, I want you to start by just graphing cosine x and sine x. So what you should see is they are identical. They are just shifted in, basically shifted in time. Okay, now I want you to graph we're going to graph cosine x, 3 cosine x, and 1/3 cosine x. So you can get rid of sine. Just like we did before, we're looking at this effect on the amplitude. Okay, so it looks like this. Everybody see that? Okay, now let's look at cosine x, cosine 3x in the parentheses, and cosine 1/3 x. So you should see that it's shifted horizontally, where we're stretching it with the 1/3 x and we are shrinking it with the 3x. The amplitudes are the same, but your zero crossings are different. Okay, now you should see if you still have it at -3 pi to 3 pi, you're seeing one cycle of the cosine there for the cosine 1/3 x. For the others, you're seeing multiple cycles. Are there any questions so far? Okay, now I want to graph sine x and cosine x minus pi over 2. So cosine x minus pi over 2, and then close your parentheses. So close your parentheses after you subtract the pi over 2. Okay, so there comes the first one. What do you see? They're exactly the same. So one just goes over the other. Why? Because cosine and sine are just shifted by 90 degrees. So I can get the cosine from the sine or the sine from the cosine. So now I want you to plot the cosine x. And then sine x plus pi over 2. Cosine x and then sine x plus pi over 2. What do you see? They're the same, okay? These are basically the same waveform shifted 90 degrees. Does everybody understand? Was everyone able to see it? Okay, we really don't have enough time to do any more, but let's just go over the homework. So we're going to then work with this on Monday. We'll start solving problems on Monday. So first, for 26, 255 degrees, you should have had 75 degrees for your reference angle. 28, 48 degrees. 30, Abigail, what'd you get for 30? 30 was a hard one. I have, oh. 30, they gave us negative 6, okay? So negative 6.28, 3.14 is pi, right? And then negative 6.28 is 2 pi. So negative 6.28 is all the way around the circle. So the difference between negative 6 and negative 6.28 is 0.28 radians. So that was a harder one. 32, what'd you say you got for 32, Abigail? 1.5 over 7. I have 3 pi over 7. So we had, I think it was 18 pi over 7, right? So 14 pi over 7 is 2 times around the circle. And then if we go to 18, we've gone to 4 pi over 7. So at 18, we've done 4 pi over 7. We have 3 pi over 7 to finish it. Okay, so just fix it if you didn't get it. 34, Jaden?
60 degrees.
Good. 840, we go around to 720. We go around twice. Once, 362, 720. Then we're going all the way to 840, okay? So 840 is 60 degrees. So we've added another 80. We've added another 120 from 720 to 840. We're here in the second quadrant. So now we have 60 degrees to go till we reach that side. Okay? Did anyone get 36? Jaden?
I got 70 degrees.
Good. Negative 650. So you go around once, negative 360. Then we have to go to 650. So how much do we have left to go from 360 to 650? Okay, it's 290. So we go around once and then we go 290. Then we've got another 70 from 290 to get to another 360. So it's 70 degrees. Did anyone else get that one? Abigail, do you have 38? Good. Our reference angle was 60, and the cosine of 60 is 1/2. We're in the fourth quadrant. It's positive. 40. Kaylee?
I have -2 radical 3, 1.5.
Good. We're at 150, so our reference angle is 30. We're in the second quadrant, so you have to put in a negative. The secant is 1 over the cosine, so we get 1 over the cosine of 150, or so secant of 30, and we put the negative in. 42, Jaden? Good. We went 7 pi over 6, so our reference angle is pi over 6. And then it was cotangent pi over 6, which is radical 3. 44, Abigail? Good. Tangent negative pi over 3 was our reference angle. You stick the negative in. 46, Kaylee? Good. We had cosecant negative 510. Our reference angle is 30. So we get negative 1 over sine 30, which is negative 2. 48, Jaden? Oh, did we stop there? Okay. So you also were supposed to go through SP5, which is, that was the last SP problem. Abigail, do you have A? Kaylee, do you have it?
105,000.
For 5? A, okay, it should be 30,000 kilograms meters per second south. Okay, the test is Monday, right? So you want to understand this stuff. We had something moving north and something moving south. So it was 1,500 times 25. They're going in opposite directions, so you wanted to subtract them. The other one's moving south, so minus 4,500 times 15. You get the difference between the two, and it's 30,000. B, Jaden, do you have it?
I get 5 meters per second. So
Okay, good. So then we divide by the sum of the masses. What is the velocity just after the collision? So we take 30,000 and divide by the total sum of the masses, which is 6,000. So we get 5 meters per second. What is the total kinetic energy before the collision? Now you need to know how to do that too for the test Monday. So you're adding them, you're not subtracting them. Because with kinetic energy, we don't care about direction. So you have 1/2 times 1,500 times 25 squared plus 1/2 times 4,500 times 15 squared. You should get 975,000 joules. Then after the collision, you have 1/2 6,000 times 5 squared. You get 75. 75,000 joules. The collision is inelastic. The vehicle stuck together and kinetic energy was not conserved, so it is not elastic. You need to know all that stuff for the test Monday. Do you understand? So we're just doing our usual. You have a lot of problems in your notes. Things colliding in the same direction, you add. Opposite directions, you subtract. All the ones we worked out, they stuck together. Are there any questions about the test Monday? Got your equations right here. Those are the only ones you need to know. It should be an easier test for you than what we've done. Okay. So all you have to do is study for the test Monday. You don't make sure you read over the chapter and know the concept questions.